Hi guys, welcome to this revision session on life cycle of a star. So this is for P8 for space, this is just for separate sciences. What we're going to be doing today is we're going to be looking at what a proto-star is, the life cycle of a star, how energy is produced in stars, and how heavy elements are made in stars as well. This is quite a small topic, but the questions that you normally get can either be ones of linking things in order, or they can be quite a long written question. So let's have a look. So to start off with, this is something that we've talked about before. This is called a nebula. It is a large cloud of dust and gas in space. Now, they're quite cool. There's some different types of nebula. These are four very famous nebulae. We have got the eagle, the crab, the helix, and the horse head, because it looks like a horse's head. Now, what happens in space is that these nebula, they start to contract because of gravity. So it takes millions of years for this to happen, but the gas particles are attached to each other via gravity, and they very, very slowly come together and they start to contract this cloud. And the more and more they contract, the easier it is for them to pull more and more dust and gas particles together. And what's going on there is that the gravitational potential energy is converted into kinetic energy. So these particles, they start moving around faster and faster and faster. They start colliding more and more. And what happens is that this kinetic energy is essentially turned into heat. Particles start to heat up, they start moving faster and faster, and here we essentially have a hot ball of gas that is nearly ready to go to the next stage. This is called a proto-star. The important thing is distinguishing what a proto-star is compared to a normal star, and that's where we need to know about this process. Because when a proto-star turns into an actual star, it's because it's doing this. Nuclear fusion, which is how energy is produced in a star. So in a protostar, it's not quite hot enough for fusion to happen, but in a main sequence star, it is. And that's because the particles are moving fast enough they can overcome the electrostatic repulsion from just having single protons in hydrogen nuclei, and therefore they can come together and they can fuse to make larger nuclei. Obviously, you might look at this and go, that doesn't seem quite right there. Yes, this is just a simplified version of what happens in fusion, and the power is just there for dramatic effect. So you have a protostar made from a nebula, which is the beginnings of a star. It's not quite hot enough for fusion to happen, but when fusion does happen, it is now producing light, heat, and electromagnetic radiation, and also heavier nuclei. So when it's going through its main sequence, what happens is we've got some forces involved. We've got the force of the heat pressure. So in fusion, where heat is given out along with electromagnetic radiation, this is providing a force going outwards that's trying to push the star out, making it bigger. But we've also got the force of gravity acting against it. The force of gravity is attractive, pulling the star in. Now, in a main sequence star, those forces are in equilibrium. They are balanced, which means the size of the star should stay the same. So if we look at this, this is going to be a familiar picture about the life cycle of a star. There may be one or two extra things I've added in here because sometimes they don't include them. So what we're going to do is we're going to talk about the life cycle of a star. Now there's two different routes as well that we need to look at. So to start off with, we have our cloud of dust and gas, which is a nebula. That will contract together due to gravity over millions of years, becoming a protostar. Remember, not quite hot enough for nuclear fusion. But once nuclear fusion starts, it becomes a main sequence star. Now, I'm going down this route to the bottom. This is sort of a star that's about the same size as our sun or smaller. So main sequence star will go through nuclear fusion, and it will give out light, heat, and electromagnetic radiation. As we said, the forces of the heat pressure and the gravitational force, they are balanced. So the size of the star remains the same. But as the star starts to go through its life cycle, it starts to run out of fuel. So in our star, the basics of stars, hydrogen is the fuel. It starts to run out of it, and therefore fusion, the rate that fusion happens, starts to decrease. And as the rate of fusion decreases, therefore you have got the rate that heat is produced also decreasing. Therefore we've got those forces now, and they're not in equilibrium anymore. The force of gravity is going to be much greater than the force of the heat pressure. So what happens is that the center of the star, because of gravity, starts to now collapse, and it starts to collapse and get smaller and denser. The outside of the star, which is mainly just gas and plasma, is now moving away from the star because the core has collapsed. And now it will appear that the star gets very, very big. And this is what's going to happen to our sun in a few billion years' time. We've still got enough time, don't worry. What's going to happen is the inside's going to collapse and the outside's going to expand, and it's going to become this thing called a red giant. Now, the outer surface of the sun is going to expand so much, it will probably get to something like Mars. It's going to expand a lot. So if we're on Earth at that time, we're going to be in trouble. So what will happen is that this outside layer of gas and dust will just literally float away into space, and it may be attracted to other dust and gas eventually and form a nebula, which then another star in the future may form from. It will not only have things like hydrogen in, it might have heavier elements in as well. So when the core collapses, it does cause a bit of an increase in pressure and temperature, and you can make slightly heavier elements in there. So there won't just be hydrogen, there'll be slightly heavier elements, maybe things like helium, lithium, etc. But meanwhile, that core of the star has collapsed and it becomes very dense, and it's called a white dwarf. Now, the reason why it's white is because it's also quite hot. There's no more fusion going on though. We've run out of our fuel. Fusion has stopped. So this is just sort of residual heat that we've got from the previous star. And all this white dwarf does now is it cools down. It's just quite a small, dense star in space. No fusion's going on. No new elements are made. It's literally just cooling down. And as it cools down, it will start to change colour. So it'll go from a white dwarf to a yellow to red, etc. And eventually it becomes a black dwarf. It will just become cold and won't really give out any electromagnetic radiation unless it absorbs it. So that's the life cycle of our sun. And then if we look at something that's a bit bigger, what we've got is we go from a nebula to a protostar, and then we've got a main sequence star, same thing as usual. Fusion's going on. This time, because we've got a greater mass, our main sequence star is bigger. And again, what will happen is the fuel will run out, fusion will stop or it will reduce, the inner of the star will collapse and the outer will expand. And this time it's going to be a lot bigger than our red giant. This is going to be a red supergiant. It's going to be much, much bigger. But the collapsing core, this time, because it's incredibly dense, what it would actually do is it will form an explosion called a supernova. Very, very bright, very, very energetic explosion that happens in space. Sometimes they can see them for days, weeks happening. With these supernova, the result from it, you either get a neutron star or a black hole. So a neutron star is an incredibly dense body. It's very, very small and a couple of kilometers across, but very, very heavy. And this is mainly made from neutrons. And then we've got a black hole, which I'm sure you've heard about, where you have a point in space, a singularity, where there is a massive amount of gravity. Things like not even light can escape, and it will be attracted towards a black hole. Very, very interesting. We think we've got one at the center of our galaxy and the center of most galaxies as well. A lot of questions we could ask about black holes, but probably not just for now. Now, there's one or two other things we need to talk about with this. We need to talk about heavy elements, because we've talked about hydrogen in the stars to start off with, and it fusing together to make things like helium, and then maybe lithium, where you have a supergiant. But how do you make heavier elements? Heavier elements are made sometimes when stars collapse in things like supergiants and in supernova, because you get a lot of heat and pressure cores it fuse them together. Sometimes what happens is that when a star collapses, it can actually heat up, causing fusion again of heavier elements because it's got an increased pressure, and the star will just keep going. But you will get elements like iron made, up into iron, made in just your regular main sequence star or a red supergiant once it's collapsed and started a star again. But iron, beyond that, you have heavier elements. They are made in a supernova. So we have a very, very hot explosion. That's where you get elements made heavier than iron. So elements lighter than iron are made just in main sequence stars, and then elements heavier than iron up to uranium, which is the heaviest natural element, they're made in supernovas. With a supernova as well, the thing that a supernova would do is, because it's a massive explosion, it will send all of this debris, all of these elements into space. which is then how they spread out into space, possibly turn into something like a meteor or an asteroid, and then that will enter planets' atmospheres, which is how we think maybe this is how we had elements in the first place. So that is pretty much it. There's a black hole there, as we talked about. This is one of the possibilities. The reason why stars become a black hole is usually because they're the heavier stars that turn into a black hole. As we said, possibly at the center of our galaxy, we think that our galaxy is rotating around it because it has a very large gravitational field. Right, that's everything. Hope you guys enjoyed. See you next time.